Hello all, welcome to CAD Technologies. Today we'll be learning how to make a flange coupling assembly, their components and how do we assemble them together. As you can see on the screen, there is a complete exploded view shown to you with the number of parts and a bill of material table. There are different balloons to describe what is what, and we also have a composite drawing of every individual parts. Like for example, I have a flange, so I have a detailing for the flange too. Similarly, I have plates, I have a plate as well. So there are detailing of every individual parts as well as the complete assembly. So in this video, I will explain how to make every single component step by step, and finally how to make the assembly of the flange coupling. Now, let's begin by making a simple flange as you can see on the screen. The flange actually has two views. The third is the detail view. You have the front view as well as the right view, and as you can see they're all cylindrical components. That means it's a cylindrical. As you can see they're all diameters. That means it's a cylindrical component. The section view is cut at this location for better understanding of the internal cuts. Now, to begin making the flange, under your start you can directly use your part design, and I'd like to use the right view to begin making my sketch. Now, any command you are flexible with you can use here to create these kind of a feature. We can use a shaft command, so I am flexible with shaft, so I'd like to use the shaft command. Now let me check for the right view and then start beginning with my sketch. This is my axis. I'll take the complete body this way, which is a 125 dia up to 30. So I'll make it only in one direction because I need not maintain any symmetry. So this is supposed to be 125 and the length is supposed to be 30. It creates a shaft as you can see. Let me take the isometric view and say okay, it creates the shaft. Now, there is an internal groove feature as you can see in the drawing in the right view. This groove is an internal cut with 105 and 35 as the diameters for up to depth of 15. The same view, the better view can be understood in the 3D as you can see. So let's try to make this feature by using our groove command. Groove is actually used to remove the material in a cylindrical manner. So we'll be following the same process like we have done earlier, how to select the edges and references, etc. Now, once I exit, it automatically removes the material as you can see. This is the groove cut. Now, you also have small cut over here. You can do that cut as well. As you can see, it is a small cut over here. So before that, let us cut this and then get the shape, or you can do it in one attempt as well. So to remove a material, we can use a pocket command on the face. Let's try to flip the body. Now, on the exact center or anywhere I'd like to make it, and then maintain concentricity with the existing body. We know that this is supposed to be 20, and there is a small detail view given which is 3 by 3. So let's try to make that as 3 by 3. So rectangle over here, and let me try to make sure that this is coinciding on the circle and maintaining symmetry with respect to the center. 3 and 3. Let's remove whatever is not necessary for us and try to cut this material. This material is cut up to the next surface, so we can do it. I think I've got it onto the other side. Let me try to rotate this. And let's try to remove the material, as you can see, until the up to next surface. This is your slot cut. Now we have holes. As you can see, there are 5 holes with in a diameter of 70. So let's try to continue giving those features. Take a sketch. We know that the reference is actually 70. So let's try to take the 70 by giving proper dimensions. And let's try to coincide this on the circle and the center. Now, the circle is actually 20 through and it has 5. So I can use a pattern to do that. The pattern which we are going to use is actually a circular pattern. So you can use a circular pattern with complete crown. We require 5 copies of the same with respect to this as the axis or any cylindrical body. It creates 5 copies. Now, last but not the least, there is a chamfer operation given to the corner, which is this corner. So you can just directly select it and give chamfer. It's supposed to be 3. So let's give it as 3 and say, okay, this will be your chamfer. Let's try to save this file and then continue with the next part, which is our flange. Let's continue with our plate next. Now I've closed the previous part. Now the next one is actually a plate. So let's start by taking a new part. It's very simple. You can either use a shaft or an extrude, but the overall dimension is 110. So let's try to take that as 110 and then try to use a simple pad command and try to take a circle and give it as 110. The addition of material for this is only up to 5, so let's try to give it as 5. Now, like how we have done for flange, we can continue the same with the whole feature in the same manner like we have done. We know that the center is this with 70 as your PCD. It's already given 70 here and it's located exactly at the center. So let's try to place it at the center and say exit, and the diameter is 20. It's up to the next surface. We need 5 copies of the same, so you can directly use circular pattern, which we have done pretty much the same thing last time. We have 5 copies with reference to the reference element and say okay, create 5 copies. Now let's save this as plate like how we did last time. Continuing with our modeling, we have a key as well. This is also a little easy to do it. Again, under my part design, I'm working on it. It's a very simple key. I'll be using the front view directly, and then I can just directly make 20 and then work on it. So I'd like to maintain symmetry. And we know that the overall length is 20. And of course, the height is 3 because it said 3 typical. And this is supposed to be added equally onto both the sides. I want to do it symmetrically on both the sides to 3, which is 1.5. This is the key. The key is actually sometimes slanted depending on the model. You can keep it a slant hole as well. Now, the next one is to make a pin. So you can make a pin directly, as you can see. So I like to use a shaft command. Again, the reason why I'm using a shaft command is because it's more simpler to make it using shaft rather than making it with extrude. I can directly make the profile and then start adding the material. That is probably why shaft is a little more easier for me. Go this way and close it. Now we know that the dimensions, overall dimensions are already given. This is supposed to be 10 and this is supposed to be 55. The overall dimension from here to this face is 30 and this is 20. Once I exit, it creates the bolt, as you can see. It creates the pin, as you can see. So once I save it, I can save it as pin and say, okay, this will be your pin. Now, similarly, you can work on the shaft as well. As you can see, the shaft. Again, depends on how you like to do it. You can do it. It's a complete diametrical component. So again, I'm trying to use a shaft. You can use pad as well. There is no issue with it. This is actually 20 and the overall length is 75. We'll make that slot cut a little later once we're finishing with the modeling. Now we can try to make the short slot cut from this location, which is F3 typical. So it should be coming on the right side. So let's try to make that first and then check if it's coming onto the right side. On the right view, it's supposed to be at this location. So let's try to use our references and then try to make a sketch. It's easier for me this way again. So let me try to go back to my isometric view and check if I'm doing it correctly. This is actually correct. Now let's try to maintain symmetricity and then start removing the material. I'd like to maintain symmetricity with respect to the center, and I'd like this feature to be on the circle. This is not needed for us. You can directly select a point, select the center and also do it. So this will be your arc, which cut we are supposed to make. This is supposed to be 3. This is supposed to be 3 as well, like how we have seen in the earlier, in the first model, which is your flange, exit. The cut is not up till next, but it has a certain distance provided to us, which is 50. So let's try to take that as 50 and then say okay. It creates a slot cut. You can then give your chamfer operations, which is 0.5 to the complete edge, and then say okay. It takes the chamfer operation. You can save the file and with a shaft and say okay. Now, last but not the least is the washer. Washer again is very important for assembling few components. So you can directly use pad or you can use anything you like. Here I am trying to use a pad command of 25 dia. And then add it up to 10. There is a hole exactly at the center which is 20 through, so let's try to take that as well. Which is 20 up to the next. This is my washer. These are all the components which we are going to use to make the flange coupling assembly. Now let's see how to make the flange coupling assembly as such using our assembly. Now, continuing with the flange coupling assembly, to do this we have to enter into our assembly workbench. So we can go into a start, mechanical design and use your assembly design. Firstly, here I'll be calling the component existing flange as the first component and then start placing other ones using our various assembly constraints. So to begin calling the first component, we can directly use an existing component. Now, clicking on existing component and then selecting the product, the first one is flange. So let me try to open that. This is my flange. This needs to be actually placed this way. I'm placing it this way because my isometric view is a little different in comparison to this one. So let me try to place it as my convenience goes into the isometric view, and I'd like to fix the first component. Now, behind this, there is a plate, as you can see. This is your plate. So let's try to call the plate as well using our plate and then try to place it at the location. Now the plate is actually interfered with the previous part. So let's try to move using our manipulation. This is supposed to be moved. And then just let me try to click on update so it goes back. Now I can directly place the constraints and then place the plate directly behind the feature. Again, I'm trying to take the constraint. I want these circles to be in line with each other, and I want this plate and this plate to be in coincident with each other. So once I say update, it auto does that for you. Now, we have another one as well, which as you can see, there's another flange. So let's try to call that flange too. And it has to be rotated to a certain distance. So I'll be using motion, this manipulation to move the body. Manipulation, I can't move this. This is the flange. Okay, just update the model. Now, this flange is supposed to be onto the other side. So when I move it, I can actually rotate the component as well using any axis I like. It's actually supposed to be this way. Now let's try to start giving our constraints. As I have positioned it as I like, let's try to give the constraints. This is the first constraint, and I want this and this to be in line with each other. And the last one is wherein this particular back feature should be in line with the back face. So once I say update, the body goes and sits there. This is your flanges as well as your plates. Now we can actually place the bolts, which are actually pins, which are actually 5. So let's try to call them and then do it. These are all in patterns for me, so I can use reuse pattern now. Again, I'm trying to select. I'm calling the pin. I'll do the rename of the component. Now, this should be in line with this face. This is my